everybody. Welcome. Thank you so much for joining us today. My name is Kelsey, and I'm joining you from Berkeley, California. So, good morning, good afternoon, wherever you are joining us. I'm really excited that you're here. I know for a lot of you, you're probably just about out of school or close to it. So, I'm beyond honored that you've chosen to spend part of your summer here learning some SAT or ACT math strategies with us. I'm really excited that you're here, and I'm really excited to teach you some of the approaches to problems that we're going to cover today. So the subject of what we're going to cover is when math is a real pain in the you know what. And if you've done any SAT or SAT math practice, you know that sometimes the word problems can look a little different than what you're used to in your high school math classes. So I am not here to teach you how to do algebra, but what I'm going to do is show you how to not do algebra, how to use some strategies to increase your accuracy, decrease the amount of time that you're spending on problems on these tests, and ultimately get your score up in a painless way, as painless as possible. And so I'm really, really excited to get into this with you. Um, so if you're ready to get going, grab a pencil, grab a piece of scratch paper, get a calculator. We are going to go through some problems today that all look pretty different. But what's really cool is that we're going to use exactly the same approach to get to the right answer, and we're not going to use algebra hardly at all. So if that sounds good, we'll go ahead and take a look at our first question. So this is a standard SAT or ACT math question. It's got more words than numbers. Some of these can feel more like vocabulary tests or reading comprehension. A lot more involved, a lot more understanding goes into these than what you might be used to in your regular math classes. So let's take a look at what's going on here with our first problem. It says, a store sells shirts for $7.50 each and hats for $5 each. The store earns $1,822 in one day from selling a total of 307 shirts and hats. How many shirts were sold on that day? So, lots of information, lots of moving parts. You might feel like you need to start trying to scrawl out some sort of algebraic equation. That's kind of what you've been conditioned to do when you see a problem like this. But what we're going to do is take a different approach. Have you ever had the experience when you've gotten a question wrong on a homework assignment or on a test, but then when you see the right answer, something kind of clicks? You're able to take that right answer and work the problem backwards, and that shows you kind of how it all fits together, and you're able to understand the right way to solve the problem. We're going to use that approach, that niceness that comes with, knowing what the right answer is and working backwards, as an actual strategy to approach these questions from the get-go. So what we're going to do is take a look at these answers and pretend like one of them is right. So what we're asked to find is how many shirts were sold on that day. So what these answers represent, A, B, C, or D, is the number of shirts. And these are our only options. It was only 37 or 89 or 118 or 202. So we're not worried about setting an equation and solving this from scratch because we know it's going to be one of these four numbers. So let's take a look and see what would happen if we just pick one. Let's pick one in the middle. So let's see what happens if B is the number of shirts that we have. And instead of trying to solve the problem all at once, let's take it one step at a time. So if we have 89 shirts, what's the next little piece of this problem that we can figure out? What's one more thing that we know? Well, we know that the store sells the shirts for $7.50, so probably we can figure out how much money they got from selling shirts if they sold 89 shirts. So we can figure out how much money came from those shirts. And this would be a calculator question on the SAT, so feel free to calculate along. What we're going to do is just multiply this by 750, and that's going to give us the total amount of money that came from shirts that day, provided that we had 89 shirts. And that's going to give us, I'll wait for you to grab it, that's going to give us $667.50. Okay, but that's not all that was sold on that day, right? They sold shirts and hats. So what's the next piece that we can figure out now? Well, they sold a total of 307 shirts and hats. So if they sold 89 shirts, we can figure out how many hats were sold. So let's do that next. And this is a basic subtraction, of course, but it's just made to be more difficult in the context of all the information given in the word problem. But we can figure this out one step at a time. So we're going to take 307 total items sold and subtract the number of shirts, which was 89. And that's going to give us the number of hats sold that day, or 218. Okay, still not done, but we do know that if 218 hats were sold and they were $5 each, we can figure out how much money came from the hats. So we want to multiply the 218 hats times the $5. That'll give us the total amount of money, which was $1,090 for those of you following along at home. So we have those two amounts that came in from selling the shirts and hats. And how do we know if that's right? How do we know if the answer here is B? Well, we also know that the store earned a total of $1,822.50 in this day. So if we add these two values together, they should give us that number. So we can punch in our calculator and add them together and see if that works. And that's going to give us 1,757 and 50 cents. So that's not quite right, right? We were looking for $1,822.50. So what we can do is we can eliminate answer B. And we can also eliminate answer A. And that's because this value that we got for the total amount of money that came in this day, it's too low. So if 89 shirts wasn't enough, 37 shirts isn't going to be enough either. So we can eliminate A and B. So now let's try the next one. And if we try C and it's not big enough, then we don't even have to calculate D. We'll know that D is right because it's the only one left. But since we've already worked through this once, we're going to do the exact same steps. So provided that answer C is right, provided that we're starting with 115 shirts, we're going to calculate how much money came in from the shirts. So we're going to do the same thing, multiply by 750, and that's going to give us $862.50. Okay, moving right along, now we can calculate the number of hats that we have if we have 115 shirts. Same calculations, different number of shirts to start with. We've got 307 items, we subtract 115 shirts, and that's going to give us 192 hats. And to calculate the amount of money that came in from those, again, multiplying by the cost of the hats, which was $5. That'll give us the total that came in from the hats. That'll be $960. I will get to that question in just a second. As I add these two numbers together, this is going to give us the total, which is $1,822.50. See, I knew that you were going to say that. The answer here is C, by the way. This one works. We don't have to do any more math. There's a lot of different ways to approach questions on SAT math, ACT math, of course. And a lot of them you might look at and say that it would be easier to write an equation or to solve a different way. And you might be right. But what's really, really cool about what we're going to do today is we're going to do problems that all look completely different. They don't have anything in common except they're asking for a number or value or how many, and they have answer choices that are exact values. There's no variables in the answers. And so what's really nice is that you're going to see lots and lots of different questions when you take the SAT. You're not going to be able to repeat questions that you've seen before, and they're not all going to be easy like this one. So it's really great to have a strategy in your back pocket that lets you know how to get started on a question when you read through it and don't know where to begin. So I'm not saying that this is the only way to solve this question, but what I'm saying is this strategy is super valuable in learning how to approach a bunch of different questions. Okay. Are there any other questions on number 20 before we move on and see how this works with a question that looks completely different? All we did here was we picked an answer somewhere in the middle, pretended like it was right, worked through the steps, figured out which direction we needed to go in, and work through those steps one more time. And that let us know what the answer was. Okay. So what we're going to do is the same thing all over again with a question that looks nothing the same. Number 6 reads, if 4 less than the product of B and 6 is 44, what is the value of B? So again, we see it's asking for a value. We've got distinct numbers in the answer choices, no variables in sight. And we are going to do the same thing. We're going to pick an answer and we're going to see if it works. So again, taking it one step at a time. So what if we pick B again? What does this represent? Well, each of these answers are different values of B. And again, we're not asked to solve for the value of B in a total vacuum. It's going to be one of these 4 options. So we're going to label our answers here. This is the value of B. So if we're assuming that the number 6 is B, what's the next thing that we can figure out? Well, we've got 4 less than the product of B and 6, so let's just get that product of B and 6. Let's do B times 6. So that would give us here, if B is 6, that would give us 6 times 6, which is 36. Okay? And then the final step is 4 less. So we've got to translate that into what it is, which is subtracting 4. So if we subtract 4 from 36, that gives us not 44, it gives us 32. So that's not our right answer. And again, we're too low. So we can eliminate A and B because this value is too small. So let's try the next biggest one. So if we pretend like C is right, if we approach this problem and assume that B is 8, then the next thing that we can do is figure out what B times 6 is, or 8 times 6. And that's going to give us 48. And now to see if this is right, we have to do the final step and subtract 4, which gives us 44. So that checks out. That answers the question, gives us what we were looking for, and we don't have to do any more math. Again, we didn't have to risk writing an equation, getting that equation right, getting all those steps right. This is a very distinct process of picking an answer choice, running with it, and seeing if it works. And if not, trying another one. It works every time. So if there's no questions on number 6, on how we use that approach with a completely different type of question, we'll move on to one that looks even more strange than the 2 we've done so far. Okay. All right, the dreaded trigonometry, geometry, lots of scary moving parts going on here, but we're not going to be intimidated. This one says, in the figure shown above, sine of angle C is equal to the cosine of angle D. If C equals this mess and D equals that mess, what is the value of Y? So again, you want to pay attention here. We have a question that's asking for the value of something, and we only have numbers in our answer choices. So that lets us know that we can use these answer choices to help us get the right answer to this question. But because this is a trig question, we also need to know something else. It's really important to know the rule that the sine of an angle is equal to the cosine of its complement. So for example, the sine of 40 degrees is going to be equal to the cosine of 50 degrees. Complement meaning that the 2 angles are going to add up to 90 degrees. And if we look at this, we can kind of reason that out too, if you didn't remember that rule. If you remember how many interior degrees live inside a triangle, it's 180. And we've already got 90 of those accounted for here in this right angle. So whatever C and D are, they also have to add up to 90 together. So a couple of different ways we could have gotten there. And again, we're looking for the value of Y. So what we're going to do is the same thing. We're going to pick one, see if it works. So let's try answer B. Let's see if this is the right answer. So if B is the right answer, then it's the value of Y. So let's label our answers. These are all potential values of Y. And what we're going to do is see what the next thing that we can figure out is. So if Y is 5.3, then we can figure out what C is, right? C is equal to 3y minus 27. And so if we know what our value of y is, we can work that out. So that's going to be equal to 3 times 5.3 minus 27. This would definitely be a calculator question. And so if we work that out, that's going to give us negative 11.1. Okay. Now what else can we figure out? Well, we can also do D, right? D's just got that y in there, and we have a value of y that we're working with. So let's try that. D is equal to 7y minus 16. So we can get that by doing 7 times 5.3 minus 16. That gives us, don't need that extra parenthesis in there. 7 times 5.3 minus 16 is going to give us 21.1. So do these two numbers for C and D, do they add up to 90? Because if they do, then this all works out, but they don't, right? If we add C and if we add D together, that doesn't give us 90. So this isn't going to work. Does the sum equal 90? No. But that's okay. We'll just try it again, and now we've got all the steps in front of us, so we're just going to reproduce them. So let's try if C is the answer. So exactly the same process, right? We're going to multiply 3 times the value of y, which is 10.3, minus 27. And that's going to give us 3.9. Okay. Now we need to do the same thing for D. So that's going to be 7 times 10.3 minus 16, giving us 56.1. So we're closer, right? These numbers for C and D, if we add them together, they're closer to adding up to 90, but we're not quite there. So this can't be our answer either. So we know it's not B, we know it's not C, but we're getting closer. So let's just do this one more time and see if D could be our right answer. So let's try D. If y is 13.3, we can do it exactly the same way. Punch this right into our calculator. 3 times 13.3 minus 27. That gives us 12.9. Same thing here. 7 times 13.3 minus 16 gives us 77.1. And so now when we add the values of C and D together, we see that they do add up to 90. So this information that was given to us in the beginning, that the sine of angle C equals the cosine of angle D, that works. So we do know for sure that D is going to be our answer here. You don't want to be too scared of these geometry trig questions. But it's always good to take a step-by-step approach. You don't want to try to do too much in your head. You don't want to start punching stuff in your calculator before you've really understood what the question is asking you to do, but just taking a methodical approach by assuming that one of the answers is right and working through the steps of the problem is a bulletproof way to get yourself through a question that looks like this. I'll pause here and see if there's any questions on how we did this here. Looks like we're good to keep moving. So I'm excited to try another problem with y'all. This one doesn't look anything like anything we've done so far, of course, but again, we have those commonalities. It's asking for a value, and we have distinct numbers here in the answer choices. So if 2 to the power of x is equal to 8 to the quantity power x minus 4, what is the value of x? So we're looking for a value. And we've got a bunch of scary looking exponents in here, but we're not going to be worried about those because we're just going to pick something and run with it. So let's start with answer C. Let's switch it up a little bit. Let's try it here. So if we start with C, then we know that x is equal to 8. So if x is equal to 8, what's the next thing that we can figure out? Well, we know that this mess must be true, right? So let's see if that works if x is equal to 8. So that would give us something that looks like 2 to the power of 8 is equal to 8 to the power of 8 minus 4, right? If we're plugging in 8 for x there, 8 minus 4, that's going to give us 4. And this is not a calculator question. You would expect to see something like this on the no calculator section. So what do? You could crunch this on the side of your scratch paper and multiply 2 times 2 times 2 times 2 times 2, but I wouldn't recommend it. The important thing to remember when you're dealing with exponents that look a little wonky, in the words of the great mathematician Megan Trainor, it's all about that base. So we want to take the bases here and see if we can't find a common base and use those to help us to see if these two values are equal. So we've got a base of 2 on the left and a base of 8 on the right. Is there anything we can do to give them a common base? Well, if you remember, 8 is equal to 2 cubed. 2 times 2 times 2 is equal to 8. So let's rewrite this. Instead of the number 8, we want to see 2 cubed. That's replacing our number 8 there. And that is still to the power of 4. So is 2 to the 8th equal to the same number as 2 cubed to the power of 4? Well, remember when you have exponents to the power of each other, you want to multiply them together. So this is going to shake out to be 2 to the power of 12. And so they're not equal, right? 2 to the 8th is not the same value as 2 to the 12th. So we want to eliminate answer C. That can't be right. But we can try it again. Same approach. So let's check it out with answer B. Let's see if 6 works for this one. So again, if B is right, then X is 6. So we've got 2 to the power of 6 is going to be equal to 8 to the power of 6 minus 4, or 8 squared. So is that right? Well, we need to work with the bases here a little bit and see if we can't get them to look similar. We need to have a common base to really be able to compare things with exponents when we're not allowed to use our calculators. So same deal, we're going to rewrite this, rewrite our 8 as 2 cubed, and it's still squared. So multiplying our bases here when we have exponents to each other, or excuse me, not multiplying our bases, multiplying our exponents when you have that common base. 2 times 3 is going to be equivalent to 2 to the power of 6. And so we see that those two values are equal. 2 to the 6th equals 2 to the 6th. No fancy algebra, no wonky business here, just the exact same approach of working through the problem, assuming one of the answers is correct, and repeating the steps until we see one that fits. So completely different style of problem. But again, the commonalities here, looking for a value, we've got numbers in the answer choices, and we just work our way down. Once we find an answer choice that works, we're done. We're good to go, and we're ready to move on and try the next problem. Okay? If there's no questions on this one, we'll go ahead, try another here. All right, this is a longer word problem. Hang with me here. If Jane bought 3 equally priced shirts on sale, she would have $2 left over. If instead she bought 10 equally priced pairs of socks, she would have $7 left over. If the prices of both shirts and socks are integers, we've got a vocab word in there, which of the following in dollars could be the amount that Jane has to spend? Whoa, lots of moving parts. Same approach here, because we're looking for a number, which could be the amount. What is the value? And we've got numbers here in the answers. So even though there's some more moving parts here than we saw in the last problem, we're going to do the same thing that we've done. We're going to pick an answer and see if it works. So let's try B here. Let's start in the middle. So if 32 is the answer, that represents how much spending money she has, right? How much was the amount that she had to spend? So if that's true, let's deal with the shirts first. So if she started with $32 and she bought 3 equally priced shirts on sale, she would have $2 left over. So she would have spent 32 minus $2. So she spent 30 if she had those $2 left over. So if she spent $30 on shirts and she bought 3 of them of an equal price, that's going to mean that she bought 30 divided by 3 shirts, or 10. Is 10 an integer? That's a definition that we've got to know going into this problem, right? The definition of an integer is something that's not a decimal or a fraction. It's a nice round number like 10, not 10.5. So shirts shake out. That gives us an integer, so we know that that at least works. But this also has to work. We also have to get an integer when we do the exact same thing with socks. So let's see what would happen if she started with $32 and she bought 10 equally priced pairs of socks. She would have $7 left over. So what's the next thing that we can figure out? Well, if she had $7 left over, then she spent 32 minus 7, or $25. And if she spent $25 on 10 equally priced pairs of socks, does that give us an integer? No, that's going to give us 2.5, right? And that doesn't work. A decimal is not an integer. So we got an integer for shirts, but not for socks. So this isn't going to work. We can eliminate answer B. And that's okay, because we're just going to follow the exact same steps here again and try to see if one of these answer choices can work with us. So let's move up a little. If we started with $47, what's the deal? So again, with the shirts, started with 47, had 2 left over. That gives us $45. And if she divided that among 3 equally priced shirts, then we have 45 divided by 3. Is that an integer? Yep, that's going to give us 15, even. Round number, no fractions or decimals. That shakes out just fine. Now we need to make sure that that's also is true with the socks. So let's see, if we start with $47 and we have 7 left over, then she spent $40 on socks. So if she spent that $40 on 10 equally priced pairs of socks, then that's going to be 40 divided by 10 is 4. No fractions, no decimals. That's an integer. That works out fine. And now we're done with this problem as well. This one's got to be C. We don't have to try any of these other ones. Doesn't matter to us. Once we find an answer choice that works, we can be done and move right on. So I'll hang on a moment to see if there's any questions here, but I just want to point out all these questions look so different, except for the commonality that we're looking for a specific number and we don't have any variables in the answer choices. There's just numbers here. If there's friendly looking numbers in the answers, you can use those to work the problem backwards and see if it works. There's only going to be 4 choices on the SAT or 5 on the ACT. But once you work through it one time, trying again is a lot less work. So this is a really cool strategy, specifically for questions that you read and just aren't quite sure where to begin. Okay. Let's try another one. Another geometry question. This one reads, if the circumference of a circle is equal to twice its area, which of the following is equal to the area of the circle? So we're going to follow the same approach that we've been doing, but another important thing to do when you see you've got a geometry question, specifically when you don't have any figures drawn, but even if you do, it's always a good idea to write down any formulas you think you're going to need. So we see we've got a circle here, we've got a circumference in question, we've got an area in question. So just as a note to ourselves to make this a little bit easier, let's write down those formulas for us so that we just have them. We don't have to wonder, we don't have to try to pull them out of thin air. So as you remember, the area of a circle should be equal to pi r squared, and the circumference of a circle is going to be equal to 2 pi r. And it's just good to have those down anytime you encounter a geometry problem. Because if you've done some of these questions in the past on the SAT or on a practice test, you know that sometimes they give you weird and unexpected pieces of these equations that aren't super intuitive with how to put together. But when you've got the equation in front of you, sometimes you're able to see what you have and what you don't and how they all fit together. So we always recommend throwing down these formulas just to help you get moving in the right direction. So we've got our formulas, and now we're going to do the same thing, right? Pick an answer choice, see if it works. And again, starting somewhere in the middle. So let's see what happens if we start out with 4 pi. If 4 pi is the answer, what do we know? Well, we're looking for which of the following is the area of the circle. So the area is what our answers represent. We want to label that so we don't get turned around. And so if the area is 4 pi, what's the next piece that we can figure out? What else can we learn? Well, we can plug that into this equation, right? We know what the area is, but we don't know what this other stuff is. Particularly when you're dealing with circle questions, you're going to need to know the radius because that's the factor that connects all the different equations that you might be using for the circle. So we know that the area here is 4 pi, and we know that the area is equal to the equation pi r squared. So we can eliminate pi, right? If we're solving for the radius, we can get rid of pi on both sides. Then we have 4 is equal to r squared, or what's r in this case? It's going to be equal to 2. R is equal to 2. Okay. So what? What do we do with that information? Well, we're looking for the circumference of this circle to equal twice its area. So we're going to need to know what the circumference is so we can see if it is in fact twice the area. So if the area is 4 pi, we know that the radius is 2, and now we can also calculate the circumference. So the circumference is our unknown, but we do have the radius. It's going to be equal to 2 times pi times the radius, which is 2. So that's 4 pi. So does this work? If the area is 4 pi and the circumference is also 4 pi, not quite, right? We're looking for a circumference of the circle to be equal to twice its area, and those are the same, so that's not what we want. So we can eliminate C. So now, again, just pick another one and try it out. We could do B. You could. But if you start to do this, what you're going to get is that 2 is equal to r squared, and you're going to have to do the square root of 2. And I don't want to. I don't think we have to. There's some friendlier looking answer choices that we can choose from here and see if they work. So we'll come back. We'll deal with 2 pi if we have to, but I don't want to yet. So let's try the friendliest looking of them all, which is just pi by itself, one single pi. If the area of the circle is pi by itself, then we know that pi is equal to pi r squared. And remember, if you don't see a coefficient in front of something, the understood coefficient is going to be 1. So again, eliminating pi here. So we have 1 is equal to r squared, or r is just equal to 1. Same steps here. So if the radius is 1, then we can calculate the circumference. The circumference is going to be equal to 2 times pi times the radius, which is just 1. So this equals 2 pi. So now we want to check and see if this matches up with the terms of the problem, which is the circumference of the circle equal to twice its area? Well, if the area is pi, and if the circumference is 2 pi, then that works. That's all we need to do. We did not need to mess around with the square root of 2 here. We don't have to check any of these other answers. We're good to go. This is going to work out just fine. If the area is pi, the circumference is 2 pi, that gives us the double circumference that we were looking for based on the terms of the problem. And we never had to touch an equation. We never had to write anything. We didn't use any algebra. Just a quick and simple way to approach this question one step at a time without getting bogged down in the details here. Really, really cool approach. Okay, so if there's no questions here on number 8, we've got another one to try out together. Let's see. So number 9 reads, if 12y is equal to x cubed and x and y are positive integers, what is the least possible value for y? So I want to pay attention that this one is a little bit different than all the ones that we've done so far. We've been starting in the middle so that, if we can figure out if something is too big or too small, we know which direction to go to try out the next one. But this one is asking for the least possible value for y. So all the possible values for y, as far as this problem is concerned, are these four. And so if we start with c, if we start with y is 144 and we work it all the way out and it works, and we pat ourselves on the back because we did the problem right and we got one that works, and we select c, we might still miss this question because it's asking for the least possible. So just because C is possible, just because 144 works, doesn't mean necessarily that that's the lowest possible number that's going to work for this equation. So when you see the least possible or the greatest possible, that's an indication to let you know that you don't want to start in the middle. You want to start with either the least value or the greatest value, because of this word possible. Some of these other ones might work, but that still won't answer the question for you. It's always really, really important to read these math questions very carefully so that you know exactly what they're asking you to do. So we're looking for the least possible value for y. And so that means we're going to start with the least possible option that we have in front of us, which is A. And so these answers are all representing y, all possible values for y, but we want to take a look at the lowest one, which is 6. So if y is 6, what's the next thing that we can figure out? Well, we've got this messy equation here, right? We've got 12y is equal to x cubed. So let's see what happens. We have 12 times y, which is 6. And we want to do that math here. That's going to give us 72. So 72 equal to x cubed. How do we know if this is the right answer? What do we do with this? Well, x and y have to be positive integers. So again, we've got that qualification of positive in there. We can't have a negative number, and it's an integer, so it has to be a nice round number, no fractions, no decimals. So if you've got your calculator, let's punch in, let's do the cube root of 72 and see if that's a nice round number. And if you do that, we want to solve for x, see if that's a positive integer. It's not. It's like 4 something. You don't even have to write that down. Whatever. It's not an integer, so that's not our right answer. No big deal. We'll just eliminate this one. And instead of skipping around, we want to try the next biggest one. So let's see what happens if we go with answer B. So if B is right, then y is equal to 18. Let's see if that gives us x and y as positive integers. So we're going to look at 12 times y, or 12 times 18. And that's going to give us what? That's going to give us 216. And is that equal to x cubed? Well, if we do the cube root of 216, that's going to give us a value of 6. So x is going to be 6. That's a nice round value. It's an integer. It's positive. X and y are both positive integers. And that's all we need to do here. The answer is B. We don't need to try anything else. Even if C and D work, that's not going to help us out at all, because it's asking for the least possible value for y. So this is the last question that I had ready to go. I'd like to open it up if anybody wants to go back, or has any questions about how to apply this strategy on anything that we've done so far. You might be thinking that you'd prefer to do algebra on some of those, and that's because that's what you've been trained how to do. But this strategy, it works on all sorts of different questions. It's really accurate and it saves you time. When you start to write algebraic expressions from scratch, especially when you're under pressure and you're moving fast and the problems aren't written like you're used to solving, it's really, really easy to make a mistake when you're doing that. But if you do slow down, show your work, and work through as if one of the answer choices is correct, then this strategy can be super duper valuable for you. Not for all questions, unfortunately, but for ones that are asking for a value and will have these distinct numbers that you see here in the answer choices. So I'll hold for questions for a few minutes, but In the meantime, I do want to thank you all again for giving me an hour or so of your summer. I know it's probably nice out where you are. I'm really grateful that you're here. And I think it really is a credit to you that you're spending your downtime, your free time, trying to look for these trade secrets that we have, these tips and tricks for really the best way to tackle these tests and to get more questions right and to get your score up in a way that's not too terribly painful or time consuming or frustrating for you. Um, so, if there aren't any questions, again, I just want to thank you again for your time. I wish you all the best of luck. We are always, always cheering you on here at the Princeton Review. Please visit the website. Take a practice test if you haven't already. That's a great way to see where you're at, where you need to be, what your strengths and weaknesses are. You can always take an SAT or an ACT free practice test on our website. That's just a really, really great way to get started, no matter where you are in the preparation for either test. Really, really a stellar way to get moving. Um, all right, so I will stop stalling for time then if there's no questions. Thank you all again. I hope you have a really wonderful day, and we look forward to working with you again soon. Thank you.